All right, here we go in section 5.5, and so this will be the last section of our college algebra course at this point for our summer session. And so we're going to solve a system of inequalities at this point, which we also are going to graph inequalities, which we hadn't done before. And so let me remind ourselves about a linear inequality. And a lot of times we're just going to do some lines, but we're also going to have some other shapes in here as well. A mathematical statement of the form ax, let me get my pen on here, ax plus by with something equal, greater than, less than, greater than or equal to, less than or equal to c, where the box can be replaced with less than, greater than, less than, equal to, or greater than equal to is what we refer to as a linear inequality. Now, a solution to the inequality is an ordered pair which satisfies the inequality. And there are multiple solutions for a linear inequality. You'll see that by what we represent our shading, okay? So anything that's in the shaded area would be a solution for the inequality. Now, here's some quick steps for us to follow when we're solving a linear inequality. What we want to do is transform the inequality of the form y with something mx plus b, where that something is one of these inequalities, greater than or equal to, less than or equal to, etc. We want to graph the corresponding y equals mx plus b equation, which we've done. Start with the y-intercept, graph that on the y-axis, then we're going to use our slope rise over run to get the next point. Now, if we have a less than or equal to or a greater than or equal to, what we're going to do is draw a solid line to represent that all the points on that line are included in the solution. And if the inequality that you have is greater than or less than with no equals, then what we're going to symbolize to not include those numbers is to do a dashed line to exclude all the points that are on the line. Now, this is what I like to do in step number 3, but the real thing is to choose a point, plug it into the inequality, see if you get a true or a false statement. If it's true, you shade where the point is in the area. If it's false, you shade the other part. But this is what I like to do. I like to go to the y-intercept and choose a point which satisfies the inequality, and I'll do that by example in just a second. We want to shade the corresponding half plane, is what we call those, for that line, okay? So let's do that. Let's talk about this inequality. It is of the form y with something mx plus b. So what we're going to do is graph that corresponding line. So if this was y equals mx plus b, this is b by y-intercept, so I would be at plus 1. And remember that negative 3/4 is the same as negative 3 over 4 or 3 over negative 4. It doesn't matter which one that you choose, but that will help you get to your next point. So this, we're going to go down 3 to the right, 4, up 3 to the left, 4. So if I use the first one, down 3, 1, 2, 3, over 4, 1, 2, 3, 4 would be here. If I use the next one, going up 3 and to the left 4 would be here. And now we have our points for our line, but you got to think about, do I do a solid or a dashed line here? This is strictly greater than, no equal. So in order to symbolize that we don't include the points on the line, we are going to dash that, okay? Now, here's where formally they say choose a point that's in one of these half planes. I would choose like the origin to make it easier. Plug 0 in for x, plug 0 in for y. Figure out you have a true statement. I don't care about that. If you have it of this form, y with something mx plus b, then choose the y-intercept. And I want a y value that is greater than, okay? That is greater than that line. Well, where's the y value greater than this point at 1? It is up here. Therefore, this would be the shading of my half plane. And all those points that are in that shaded area would be values that work for that inequality. So all of this is the solution. Okay, so we do the solution by a graph. All right, let's try this one. This is definitely not in the form where y is by itself. So let's go ahead and get y by itself. So I'm going to subtract 4x, and I get negative 2y greater than or equal to negative 4x plus 8. Make sure you write the x coming first, then the number. And now I need to get y by itself by dividing by the number next to the letter, which is a -2. Now I hope there is a bell ringing in your head or a flag waving in front of you that when you divide by a negative with an inequality, there was something extra we had to do. We had to flip this inequality. So I get y on this. I'm going to now make that a less than or equal to, and then simplify here. -4 divided by -2 is a positive 2x. Positive 8 divided by -2 is a -4. Therefore, there is my y equals mx plus b equation form. This being my b, which is on the y-intercept. Start from the back. We're going to go down to -4 on the y-axis, not the x-axis, the y-axis. Then we're going to make this a slope of 2 over 1. It's a positive slope, so it better go in this direction, going up 2 and over 1, up 2 and over 1. And you could keep doing that until you get off the chart if you want. Now we refer to the inequality. Does it have an equals? It does. So that means we're going to do a solid line for our line to include the points on that line. And now we go to our y-intercept, and we want to choose a y value that's less than or equal to that line. So here's my y-intercept. Less than or equal to would be below. Therefore, all of these points underneath that line will be our solutions. Okay? All right, very good. Now we get two special ones. Just as a reminder to you, if I wrote this as x equals 3, where is x equaling 3? It's right here. That is a special line where all my x values are 3, which occur all the way along this vertical line. If you recall, I told you it was one line that went through the x-axis. So that would be my corresponding line. But now let's look at our inequality. Do I draw a dashed line or a solid line would be the question. No equals, so we would have to dash that line. And I want all x values that are less than 3. So where is less than 3 x's? Well, it's all these guys over here. Therefore, this would be my half plane that would be shaded. And that would be my solution to that inequality. Okay? Y greater than or equal to -2. If I had y equal to -2, that's kind of the opposite of what we have over here with x equaling. If it's y equaling, it's going to go through the y-axis at y equaling -2. I turn my attention to the inequality, and it now this time has an equals. Therefore, I'm going to have a straight line that separates it. And now which direction do I shade, above or below? I want y values that are greater than or equal to -2. Where are y values greater than or equal to -2? It better be up top. So all of this that you shade would be the solutions to our problem. Okay? All right, very good. Now these two are ones that will require us to remember some of our other graphings. Okay? So if I have x minus 3 plus squared plus y squared greater than 4, I hope you remember that that is the equation of a circle. So this was our x minus h quantity squared plus a y minus k quantity squared is equal to an r squared. So our center was our hk, and our radius was r. Okay, and then this is where we had to take the opposite of what we were looking at. The opposite of what I see here is a 3. And the center here doesn't have anything with it, so it would have to be a 0. And if I have r squared here and I need r, I would need to square root that. So the square root of 4 is 2. So what do we square to get a 4? It is a 2. So I'm going to draw my circle. Here's my center at 3, 0. I have a radius of 2, so that means I go north, south, east, and west, if you recall, to draw my circle. Now, here's the case where, again, it's an inequality. I need to check to see if it has an equals. It does not. Therefore, my circle is going to be dashed. And I want everything, all the points that have a bigger radius than this r squared. So if it's greater than, that means we are on the outside of the circle. If it is less than, then we would be on the inside of my circle. So I would shade all of this out here and leave the circle blank. Okay? So all of those out there would represent the solutions to my inequality at that point. Okay? Now, y greater than or equal to x squared minus 1. If I said y equals x squared minus 1, hopefully you recall that a y squared is a parabola. And this minus 1 here means that we would go down by 1 because that's our vertical shift. So if I have that from my original origin, I go down 1. If you recall, the key points of our parabola was 0, 0, 1, 1, and a 2, 4. So from the vertex, I go over 1 and up 1. I go over 2 and up 4. 1, 2, 3, 4, one more. And then I have a 2 for 1 deal. It's symmetric over that y-axis in this case, so I would have these other 2 points. Now, this again, I turn to the inequality. Do I dash it or do I do a solid? There is an equal, so therefore I would do a solid line. And I want to know all the y values that are greater than or equal to that parabola. So what we have there, greater than or equal to, I would end up putting these values in here, and I would end up getting values that make this inequality true. So you could always check some points. If it's greater than, it's going to be above. If it's less than, it's going to be below. And so that would be our inequality solution for that one. Okay? All right, very good. Now, let's talk about solutions for a system of inequalities. Now, a system of two inequalities is basically two of what we were just doing together. And what we are trying to find is the overlap for our solution. So let's put two inequalities together to form a system of inequalities, and then the solution of the system of inequalities will be the overlap or the common region of the shadings. Okay, so we are going to graph both of these. Notice this is a line. It's in the y equals mx plus b form, but this one is not. So I'm going to go ahead and get it there before we start doing any graphing whatsoever. I get minus y less than or equal to negative 2x minus 6. Now, I don't want minus y, I want a positive y. So that's like a negative 1 in front of there that I want to divide by a negative 1. Now, the reason I did this one again was to remind you, when you divide any inequality by a negative or you multiply by a negative, then this inequality must be switched. Now, divide negative 2 by negative 1, negative 6 by negative 1, and you get a positive 2x plus 6 for that line. Okay? All right, very good. So let's graph this guy first. I'll graph it in blue. Okay? So I'm going to go on the y-intercept, which is a minus 3. And this negative 3 halves, remember I can go negative 3 over 2 or 3 over negative 2. Either way works. So if I go negative 3, 1, 2, 3, I'm down here over 2 gives me about there. If I go up 3, 1, 2, 3 over 2 gives me this one. I can keep doing that pattern and get this one. I turn to the inequality. There is no equals, therefore it would be a dashed line. And I want y values that are greater than the line. So y values greater than that line would be up here. Now, I'm not going to shade that per se, because what I'm looking for my final solution is the overlap, okay? So if you can do it without shading it and seeing the overlap, that's the easiest way, okay? If you need to do the overlaps and shading, please do so. All right, so now let's try this line here. If I'm going to graph that, on the y-axis I would be at plus 6, which is about here. This is a 2 over 1 slope, so I would go up 2 and over 1, or I can go down 2 into the left 1. So kind of do the opposite, so just kind of working with what we have. All right, look at the inequality. It is solid this time because I have the equals. And I want a y value greater than or equal to that line. So a y value greater than or equal to that line, which would be up here, okay? And I had, for the first one, I had greater than or equal to that line, which would be up here. So for this half and this half, the overlap is right here, okay? The overlap is right there. All right, so again, the final answer is going to be that common solution that you have for both of those. Okay? All right, let's look at this guy. Those are basic two-line ones. This is also a two-line one. It's a compound inequality that I want to remind you could be the same as -2 less than y, and y is less than or equal to 5. By splitting that apart, we had a common word or a connecting word of and I'm going to kind of flip-flop this around and make it y greater than -2. So just flip it around to where we have it. So I'm going to graph this, and I'm going to graph that. Those are going to be my two lines, and we need to determine where is kind of the overlap, okay? Now, we just had on the previous page where I had y with just a number. If you recall, that is a horizontal line. So y being greater than -2 means I'm going to have, first off, a dashed line because there's no equals, but it's going to be that horizontal line at -2. And then I want a horizontal line at y equaling 5, but I now want a solid line there because it's an equal to. 5 is up here, so I have that solid line right there at x, or y equaling 5. Now this inequality says that I have to be greater than or equal to -2, so I want all of this, even as it expands past my graph. This one tells me from y equaling 5, we want to be less than that line. So that would be all of this here. We don't want all of it, we just want the overlap. So the overlap, what is common, would be everything bouncing in between here at -2 to 5. Okay? All right, very good. So watch those tricky ones with those horizontals. Now, let's look at this one. We don't have y by itself. These are very nice to get y by itself because I just have to subtract x from each one of them. So I get y greater than -x plus 3, and I get y less than, a -x minus 2. Okay? All right, so let's graph each one of those. This one, I would go up to 3. With a negative in front, that means I have a -1 over 1 slope. So I would go down 1 over 1, down 1 over 1, down 1 over 1. Look to my inequality. There is no equals, so it is dashed. And if I wanted to shade, that means y has to be greater than that line. Here's my y value. Greater than would be all of this up here, okay? So don't shade that just yet because we've got to see the overlap. Here, I go down to -2. I actually have a -1 slope also again, so I end up going down 1 to the right one, down 1 to the right one, down 1 to the right one. And no equality, therefore it would be a dashed line there. Those look kind of special. They have the same slope but different intercepts. These are actually parallel lines that may or may not have a solution. So in this case, I want y to be less than or equal to this line, which would be all of this part of my plane. I had this one to begin with, this for the second one. There is no overlap, so that's okay. It's very possible that you might get a no solution set because there are no points that are common to both. Okay, so I wanted to show you one of those special cases. All right, the next one is a system of a circle and a parabola. So hopefully you have recognized the equations here. Let's start with the circle. And on the previous side, we kind of alluded to that formula again. There is nothing grouped with the x and y, so therefore my center is going to be 0, 0. And if this is r squared, then I square root that, and I have a radius of 3. So a 0, 0 is my center. I'm going to be out 3 north, south, east, and west. Look to your inequality. It is an equals this time. Therefore, I'm going to have a solid line all the way around, sort of, kind of. Try to hit your points there better than I did. And if I have that circle less than or equal to that 9, less than is going to be the inside of my circle. So I'm looking at all of this inside here, okay, as possible solutions. When I turn to this parabola, it's very similar to the one we saw on the reverse side. It is down by 2 this time, and then we can graph it, going over 1, up 1, over 2 and up 4, 1, 2, 3, 4. Get a mirror image point on the other side, and I have my parabola points. Now, turning to this, there is no equals there. Therefore, we have a dashed parabola to exclude all of those points. And now I want y values that are greater than or equal to that parabola. So here's my y value. Greater than would be up in here. But I also have to be within the restrictions of my circle. So actually, all of this piece in here is going to be my solution. Okay, so again, it's the overlap. Make sure that you do the overlap of each one of those two systems, whether it be a parabola and a circle or two lines, whatever the case may be. Okay? All right, and our final problem, it's going to be a system of actually 4 inequalities, okay? So we want to make sure that we will, and I actually have a goof here. Let's make this a 0. And so we're going to graph each one of these and figure out where the overlap is, okay? So x greater than or equal to 0. If I said x equals 0, remember that's a vertical line. This guy is a horizontal line at x equaling 0 and y equaling 0. So here's where x equals 0 along my x-axis. Where's my 0? It is right here. So I want a vertical line. Notice it is an inequality that has an equality. Oops, so not dash, but solid. X values that are greater than 0 gets me into these two quadrants right here. Okay? If I have y greater than or equal to 0, y equaling 0 is right here. There is an equality, so it is a solid line. And to be greater than or equal to 0 is all up here, but overlapped with the x greater than 0 would just get me in the first quadrant, so I'm narrowing myself down. Let's graph this line. This line says, okay, I'm going to have a y-intercept of 4, and then I'm going to have a slope of negative 2 over 1, so down 2 over 1, down 2 over 1, gives me this point. I look to the inequality, there is no equals, so I'm going to have a dashed line. And I want y values that are less than that. So less than that would be down here. So if we're restricted in the first quadrant, less than this line would now be this right triangle that I'm restricted down to. And where do we go from here? Well, unfortunately, this one is not set equal, or doesn't have y by itself. So I'm going to subtract 2x, and again, we're making this a 0, minus 2x. So I get negative 3y less than or equal to negative 2x, and you can do a plus 0 if you want, but you don't have to. When I divide by negative 3, again, this is the third time I've done one where you have to divide by a negative, because I really want you to make sure that you realize that you have to switch that sign, because that'll trick you up if you don't. And so now I get reducing this by the negatives and just writing it as 2/3 x. Then again, you can do that plus 0, it doesn't matter. So that means I'm going through the origin. I have to go up 2 and over 3 to give me my, give me my new point, not this one, this one. And we have an equals, so that means I'm going to do a solid line. And now I have to figure out y is greater than or equal to that line. So from here, where's a y value greater than or equal to that? It's up here. So I would graph this whole half plane, but remember we were just restricted down to this right triangle. So everything cut off into that would just be this piece right here. It almost looks like a little scaling triangle in there. Okay, so that would be our final solution for this system of 4 inequalities that we have. So that is it. That's what we have for inequalities. Please make sure that you have the y isolated if it's a line. And the other thing to remember is to make sure you have your solid or dashed line on there, and also determining where that you shade that. So be very careful on that. So until next time.